Today we are doing 10.7, which is comparing populations. We're going to be looking at two different graphs, and they're going to ask us to use measure of center and measures of variation to compare them. So measures of center, that means something that's about where the middle of the numbers are. So those options are mean, median, and mode. Measure of variation tells how spread apart things are. That would be our MAD, our range, or our IQR. So if we have a set that is symmetrical, which means if we fold it in half, about everything matches up, then we're going to use the mean and the MAD to compare them. If we have two things that are skewed, we'll be using the median and the IQR to compare them. So let's go ahead and take a minute to figure this out, or take a look at our first type of problem. So it says the double dot plot shows the time that each candidate in a debate spent answering each of the 15 questions. So the first thing we have to decide is, are these graphs symmetrical or skewed? So when we do this, we look at one graph at a time. If either of them are skewed, we consider them skewed together. We're going to start with candidate A. That's this one right here that's in blue. So I look at about where the middle would be, which is about here where I'm drawing with a line. Then I look at the points on the left and the right, and I see how they match up. So we have 3 points to the left, 3 points to the right. Those match up if we folded it. Here I have 2 points to the left, and then I only have 1 to the right. So that wouldn't perfectly match up, but they're not that far off. Then the next line out, I've got 2 on the left side, 2 on the right side. So those would fold and match. And then the very outer points here, I've got 1 on each side. So candidate A, those blue points, that would be a symmetrical graph, because when I fold it in half, almost every point has match on the other side. The same thing is true for candidate B. The line in the middle here would be this one at 60. And then we look at the left and the right sides and see how they would match together if they were folded in half. So our 50s, I have 2, and 70s, I have 2. Those match. 40 and 80, there's 1 of each. Those 2 match. And then on the extremes here, I've got 30. I have 3 points there, and I only have 2 points on the 90. So that's not perfectly symmetrical. But for the most part, if we folded it in half for candidate B, most of those would line up. So that is going to be a symmetrical graph. So since I know I'm doing a symmetrical graph, I'm going to find the mean and the MAD for these numbers. All right, so I've got symmetrical, I've got mean and MAD. I wrote that down for you up here. That's our plan. So here's how I did this, and I already have my answers down here for you. For candidate A, I'm going to scroll a little so we can see it a little better. Okay, so for candidate A, I started by adding my numbers together to get my mean. So I added one number for each one of these dots. So I added 50 plus 60 plus 60 plus 70 plus 70 plus 80 plus 80 plus 80 plus 90 plus 90 plus 90 plus 100 plus 110 plus 110 plus 120. So when I added all of those numbers together, I got 1,260. There are 15 numbers, so I divided those numbers by 15, and then I got 84. Once I did that, I had to take each one of these values and I had to subtract it with 84 to find out the distance from the mean. So for example, if I did 84 and I subtracted my 50 from this number right here, I'm going to end up getting 34. And I do that for each one of them. So when I subtract here, this one is going to be 34. Then I look at the 60, that's going to be 24 away from the mean. My 70s are going to be 14 away from the mean. 80 is going to be 4 away from the mean. 90, now I'm on numbers that are greater than 84, so I'm going to subtract that number, 84 from that number. So 90 is 6 units away from 84. 100 is 16 units away. 110 is going to be 26 units away. And then for my 120, that's going to be 36 units away. So now that I've done my subtraction, I'm going to find the mean of my new numbers. So now I'm going to add the points again, except that they're going to be using these numbers that I wrote in here in red. So I'm going to add 34 plus 24 plus 24 plus 14 plus 14 plus 4 plus 4 plus 4 plus 6 plus 6 plus 6 plus 16 plus 26 plus 26 plus 36. When I added all those numbers together, I got 244. I divided by 15, and I got about 16 3/10, which I could leave as it is, or I could round to the nearest whole number, which is what I chose to do, 16. So go ahead and pause the video for a minute. I would like you to try for candidate B. Find the mean and the MAD. Then we'll compare them together. Okay, so let's go ahead and check to see if your answers are right. So for candidate B, for the mean, when you added all the red points together and divided by 15, you should have gotten 58. So the total was 870. We divided by 15, we got 58. Then for each one of those points, you have to subtract it from 58 or with 58 to find out how far away it is from 58. So I'm not going to write them all out, but I'll write a couple here. So if I did 58 minus 30, that would have been 28. And then this one would have been 18 and so on. So you have to subtract each one from 58, figure out how far it is. And then add your new values, the distance from the mean together. That would have given you 236. We divide by 15. You should have gotten 15.7. And if you wanted to round, which you don't have to, you would round it to equal 16. They did ask us to compare here. So now that we've found the numbers, we actually have to write a sentence to compare it. So our sentence here is candidate A has a higher mean, but the MAD is almost the same. It rounded to the same value. It wasn't exactly the same, but it was very close. So for this type of problem, you have to actually calculate your measure of center. On this one, it was the mean. The measure of variation. On this one, it was the MAD. And then you need to write a sentence to compare them. Which one is bigger, or are they the same or about the same? So that's part A. There is a part B down here, and it says express the difference in the measures of center as a multiple of the measure of variation. So we have to look for some key words here to help us understand what they're asking us to do, because the wording's a little tricky. So difference means subtraction. So difference in the measures of center, that means we're going to subtract our mean, since that's the measure of center. And then as a multiple means that we're going to divide to figure out how many times bigger it is than the MAD. What that number tells us is about how much overlap there is between the two graphs. It's useful if we don't have the graphs in front of us to compare them. All right, so when we do that, we do 84 minus 58. Those are our two means. We subtract by 16. If you don't get the same measure of variation, you can pick either one to divide by. When we did 26 divided by 16, we got 1.625, so 1 in 625 thousandths. That tells us that there's quite a bit of overlap between our two graphs. And if I scroll back up, you can see that there are numbers from 50 through 90. A lot of the graphs are the same and overlapping. So there's a lot of similarity in the data. Okay, so let's take a look at this next one. What if each value in the dot plot for candidate A increases by 30 seconds? How does this affect the answers in example 1 and explain? So we're going to pause here and go ahead and write what you think is the answer for this question. Okay, let's go ahead and check our answer, see if you did it correctly. So for this one, if everything for candidate A increased by 30 seconds, the mean would be bigger. All of our numbers that we added together would be bigger. So that would give us a bigger mean. But our MAD, which tells us how far the dots are apart, that's going to actually stay the same because the dots moved together. Every single one got bigger, but they got bigger by the same amount. All right, let's take a look at our next problem here. It says you want to compare the costs of speeding tickets in 2 states. So for our first part of this problem, it says the double box and whisker plot shows a random sample of 10 speeding tickets issued in 2 states. Compare the samples using measures of center and variation. Can you use this to make a valid comparison about speeding tickets in the 2 states and explain? So they're asking us to do 2 things. The first thing they're asking us to do is to compare them. The second thing they're asking us to do is answer this question. Can we actually use this information to make a valid comparison? So let's start with this first part here, the comparing. we need to decide if they are symmetrical or if they're skewed. On a box and whisker, when we're looking symmetrical and skewed, we look at the box. If it's symmetrical, the box should be about in the center of where the two whiskers are. The whiskers should be about the same length. So if you look at state A, it's got a very short whisker on one side, and then it has a very long whisker on the other. The actual box part is pretty symmetrical. The median's about in the middle, but the whiskers are very skewed. One side is much bigger than the other. State B is also skewed. It's less, so the whiskers are closer in being the same length as each other. But as long as one of them is skewed, then both of them are considered to be skewed, which means we need to be using the IQR and the medians. Okay, so the nice thing about box and whiskers, it's pretty easy to find median and IQR. It's a lot less work than what we did on the last one for mean and MAD. Median, that's a line in the middle of the box. So for state A, here's my line in the middle of the box right there. That matches up with the number 70. So my median for state A is 70. I wrote that here. Then I found the IQR. On a box and whisker, that's the sides of your box. Our lower quartile is the median of the bottom half. Our upper quartile is the median of the top half. And then we subtract those numbers. So the top part of my box matched up with 80. The bottom part of my box matched up with 60. That tells me my IQR is going to be 20. Go ahead and pause the video and try to find the median and IQR of state B. Okay, so let's go ahead and check to see if you did that correctly. Okay, so for state B, you should have gotten a median of 80. That's the line in the middle of the box. And then the IQR, you should have subtracted the numbers 100 and 70 and gotten 30. That's the size of the box. Then we need to actually compare them. So now that we have our numbers, I wrote a comparison over here. State B has a higher median and IQR. Both of them are greater. And then the last thing that they ask us, this part right here, can we use it? And the answer on that one is going to be no, you can't use it because their sample size is too small. So now let's go ahead and take a look at the bottom part, or the next part of this problem. So for B, it says the double box and whisker plot shows a medians of 100 random samples of 10 speeding tickets for each state. So that's going to be much better to compare these two populations instead of just looking at 10 speeding tickets, looking at 100 samples of 10 speeding tickets. Okay, so we are going to compare the variability. That just means our IQR. They didn't ask us to do the measures of center for the sample medians to the variability of the sample costs in part A. So the first thing we need to do is find the IQRs for state A and state B. All right, go ahead and pause the video and try to find the IQRs for state A and state B. All right, let's check it to see if you got the correct answer. So both of those should be about 10. For state A, when we subtract, we have 70 and 60 that we're subtracting. State B, you might have had something slightly different because the numbers aren't perfectly matching up with numbers that are below them. To me, it looks like about maybe 78 and 88, but you could make an argument that the IQR is maybe 9 or 11, something in that range. And then our statement of comparison about the IQR is about the same. I added in there that state A has a bigger range. That's the greatest to the least because it does. It's also a measure of variability, but you wouldn't have to put that. As long as you mention something about the variability, then you can, that's all they're asking for. And then part C, make a conclusion about the cost of the speeding tickets in the two states. Well, looking at this information here, it looks like state B has a higher cost on average because the all of these points except for the very highest ticket. The highest ticket is the same, but for the other 4 points on the box and whisker, it's higher for state B. So it looks like on average, state B has a higher ticket cost. Okay, let's go ahead and try this one. Number 2, what if a random sample of 8 speeding tickets issued in state C have a median of $120? Can you conclude that a speeding ticket in state C costs more than state A and B, and explain? Go ahead and pause the video and write down what you think. Okay, let's check your answers. So on this one, I would say no, there's not enough samples to make a conclusion. Here it says that there's only 8 speeding tickets. And when we're comparing that to 100 samples of 10 speeding tickets, there's just not enough good information there to make a claim about the cost of tickets in State C and State A and B. All right, and here is our last one for today. Writing prompt to compare two populations. What do you need to do? How do you know what to compare? Go ahead and pause the video and write down your answer. All right, let's check to see if you are correct. So to compare two populations, if they are symmetrical, we're using the mean and the MAD. If they are skewed, we're using the median and the IQR.